Hey everyone, welcome back to my channel. In today's lesson, I'm going to solve questions given in the Mathematics 1 study guide, which is provided by University of London for their EMFSS programs. And the chapter name is Matrices and Linear Equations. The first question is as follows. Question number 6.1. Express the following set of equations in matrix form and hence solve them using a matrix method. So let's first convert this in matrix form. 1, 1, 1, 2, minus 1, 1, 1, 3, minus 1. We have three equations and three unknowns, x, y, z, and we have a column, vector 1, minus 1, 7. So basically this system is Ax is equals to b, and you can either find it by finding the inverse of matrix A. So you multiply the whole system by the inverse. We know that matrix multiplication isn't commutative, but when it comes to the inverse, it is always equals to identity. So the inverse multiplied by a matrix or matrix multiplied by the inverse will give you the identity. So either you can calculate the inverse of the matrix and multiply it through, or you could use the Cramer's rule to solve such a question, or you could just construct the augmented matrix and convert it into a row reduced form and then derive the answer. So let's do method number 3, because at this level inverse calculation and the Cramer's rule is not in the syllabus for mathematics 1. So let's construct the augmented matrix. So the augmented matrix will look like this: 1, minus 1, 7. Okay. So remember, the trick is that what you want to do is that you want to use row 1 to impact row 2 and row 3. So this is going to be your step 1 always. Then you want to use row 2 to impact row 3. So, and then now we're going to make our way upwards. Then you want to use row 3 to impact row 2. And then you could either use row 2 or row 3 to impact row 1. So if you follow these steps, it's going to be very easy to get the row reduced echelon form. Okay, so let's do this. Okay. So I want to convert this into a 0, then 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 this into a 0. So this is going to be the procedure, and I'm going to have these leading ones stay here so that I can easily get the answer of x, y, and z. Okay, so the first 0 that I want to make is this and this. Okay, let's do this. I want row 2 minus 2 into row 1. I want to do this operation, and I want to do row 3 minus row 1. So I want to do this operation. Let's do this. The first row is not going to get impacted, so it's going to stay as it is. This is going to get impacted, and this is going to get impacted. So we have a 2 minus a 2, this is a 0. A -1 -2 is a -3. Then we have a 1 minus a 2. Let me put my phone on silent. Yeah, okay. -1 -2 is going to, oh sorry, we have a 1 minus a 2 is a -1, and then -1 minus, okay, -3 again. Okay. Then a row 3 minus row 1 is a 1 minus 1. This is a 0. 3 minus a 1 is a 2. -1 minus 1 is a -2. Then we have a 7 minus a 1. It's a 6. Okay. Let's multiply row 3 by a half so that I can get a 1 over here, because it'll be easier for me to make that into a 0 when we have a 1. Okay, so 2 ones are 2, 2 ones are 2, 2 threes are 6. Okay, we've done that. Now the next thing that we need to make into a 0 is this entry. Okay, let's do this. I want to multiply 3 into row 3 and then add row 2. Remember, I want to impact row 3 using row 2. Okay, let's move forward. I get a 0 plus a 0 stays the same. 3 minus a 3 is a 0. -3 minus 1 is a -4, and 9 minus a 3 is going to be a 6. Okay. We can convert this. This is a leading 1 position, so let's just convert this into a 1. So let's multiply row 3 by a -1 by 4 so that I can get a 1 in the leading 1 position. So let's do that. I'll get a 0 here, a 0 here, a 1 here, and a minus. 2 3s are 6 and 2 2s are 4. So a 3 over 2, right? So that's just a 1.5. Okay. At this point, you could either work backwards, or another thing that you could do is that you can make this should be the next 0. Okay, so either work backwards, construct 3 equations, because this is going to give you the value of z. You can substitute it over here to obtain the value of y, and then you can substitute the value of y and z over in the first equation and get the value of x. Okay, but let's just practice conversion into the reduce form. Okay, so now I want to work my way upwards. So I want to use row 3 to impact rows 2. So let's do row 2 plus row 3. Okay, then we'll get, this is being changed. This changes, right? -1 minus 1 is a 0, and then -3 minus 1.5 is a -4.5. And I would like a leading 1, so I'm just going to multiply by -1 by 3. I'm going to multiply row 2 by -1 by 3. Okay, let's cut paste this. Okay. And let's write this as a fraction. This is a 3 by 2. This is a 9 by 2. So I want, 9 by 2. And I want to divide it through by a 3. Okay. -3 divided by -3 is just 1. And 3 3s are 9. And this becomes a positive. Okay. Now we want to use row 2 and row 3 to impact row 1. So first we want to get rid of this one. We want to convert this into a 0, and then I want to convert this into a 0. So let's move on. I'm going to say row 1 minus a row 3. Okay, so we'll end up with a 1 minus a 0 is just a 1. A 1 minus 0 is just a 1. 1 minus 1 is a 0. and 1 minus a half is a minus half. Okay, this is the last um, number that we need to convert into a 0. Now use row 2. So row 1 minus row 2. Let's do this. I'll end up with a 1 minus a 0 is a 1. 1 minus 1 is a 0. 0 minus 0 is a 0. And then minus half plus 3 by 2 is just a... actually, that's just a 0.5 plus a 1. This is just a 1. Okay, so now you can clearly see the answer. X is equals to a 1, y is equals to a 1.5, and z is equals to a minus 1.5. So the benefit of converting into a row reduced echelon form is that you can see the answer immediately. The value, the answer for x, the answer for y, and the answer for z. So all you have to remember is then when you have an augmented matrix that looks like this, A, B, C, D, E, F, G, H, I, J, K, L. Okay, the first thing that you need to make a 0 is this. This should be a 0 first, then this should be converted into a 0, then this value, then this value, then this value, and then this value. Okay, so you have to follow this procedure. Convert this into a 0, then this into a 0, then this, then this, then this, then this. Use row 1 to impact row 2 and row 3. Then use row 2 to impact row 3. Then use row 3 to impact row 2. Then use row 3 to impact row 1. Then use row 2 to impact row 1. So let's do the next question. It says, high-class dressmaker makes 3 types of dresses. She makes cheap everyday dresses, medium price cocktail dresses, and expensive ballroom dresses. Okay, the making of the dresses involves the inputs of fabric, labor, fastening, and machine time. Okay, so every day requires 5 inputs of fabrics, 20 units of labor, 15 and blah blah blah. Okay, this shows the units of input required per dress for... okay, the dressmaker makes a combination of the 3 dress types, which uses exactly 270 units of fabric. Okay, let me highlight this though. So 270 units of fabric, 1050 units of labor, that's the total labor, 790 units of fastening. How many types of each of dress does she make? What is the corresponding machine time use? Okay, what is the corresponding machine time use? Okay, so let's just denote X as the number of everyday dresses, and Y as the number of cocktail dresses, and Z as the number of ballroom dresses. Okay, so since we have 270 units of fabric, this would mean that 5x plus a 6y plus 8z should be equals to the amount of fabric available, which was a 270. Similarly, 20x plus 25y plus a 30z should be equal to the total number of labor available, which was a 1050. Moving on, 15x plus 20y plus 22, z should be equals to 790. And then we are not basically given any constraint on the machine time, so we can't actually make any correspond fourth equation, because we'll end up saying 7x plus 9y plus 12z is equals to some other kind of unknown m. So we can't have a fourth equation. A fourth equation is only possible when you have four unknowns. Okay, so at the moment we have three unknowns. The unknowns are x, y, and z. So if we have three unknowns, then in order to have a solution, we require three equations, not four. If you had four equations, then you would have required four unknowns. Okay, so now let's convert this into a matrix form. We'll have 5, 6, 8, 20, 25, 30, a 15, 20, 22, and the column matrix vector is going to be the unknown variables. And now we have our resource constraint. Okay, so we want to convert this into the augmented matrix, and we then want to, I've already done the row reduced echelon form. We'll just do the reduced echelon form this time. So what that means is that we're going to make this into a 0, this into a 0, and then this into a 0, and then we're just going to use backward substitution to get our final answers. Okay, so we can do, remember we have to use row 1 and we want to impact row 2 and 3, right? So we know 5 fours are 20, so what we can do is we can write row 2 minus 4 row 1, and we can do row 3 minus 3 row 1. So let's move forward. I'll have a 5 here, 6 here, 8 here, 270 here. I know this becomes a 0 and this becomes a 0. Okay, now 6 fours are 24. So 25 minus 24 is just a 1. Then we have 8 fours are 32, and 30 minus 32 is just a minus 2. Then we have a 270 multiplied by a 4, which is a 1080. And if we subtract this from a 1050, we're going to get a minus 30. Okay, in the last row, we have a 6 threes are 18, and we want to subtract that from 20, so we'll get a 2. Then we have 8 multiplied by 3, which is a 24. We want to subtract 4 from 22, so we'll have a minus 2. And then we want 270 multiplied by a 3, which is a 810, and we want to subtract that from 790, which gives us a minus 20. Okay, now the next step is to make this into a 0. Let's first multiply equation, the last row, by a half, because that gives me ones and they're just basically easier to work with. So I'll get a 0 here, a 1 here, a minus 1 here, and a minus 10 here. Okay, I want to do row 3 minus row 2. Remember, I want to use row 2 to impact row 3. So then I'm going to get the following: a 0, a 0, a 1, and then a 20, right? Okay, so now let's make our way backwards. This is known as the reduced echelon form. Reduced echelon form. I hope I'm like right about this because it's been a while since I did algebra, but I think this is called the reduced echelon form, and the row reduced echelon form would have zeros over here as well. Okay, so what the last equation tells us that the value of z is equals to a 20. The second row tells us that y minus 2z is equals to a minus 30. So therefore y is equals to a minus 30 plus 2z. And we just found out the value of z, which is a 20. So this becomes a minus 30 plus a 40. So we have a 10 here. And then we have the value of x. So we have a 5x plus 6y plus 8z is equals to a 270. So we have a 5x plus 6 into a 10, which is a 60, plus 8 into a 20, right? That's a 160. And we have a 270 here. So a 270 minus a 160 minus a 60 is basically a 50. So we have 5x is equals to a 50. So therefore x is equals to a 10. So our solution is that they should make, what was x? Okay, so everyday dresses should be 10. The, what was y? Y was cocktail dresses and Z was ballroom dresses. So 20 ballroom dresses. So we want to find the corresponding machine time used, okay? So since now we have the value of x, y, z, it has to satisfy this equation. So let's find out the value of m. 7 multiplied by 10 plus 9 multiplied by a 10 plus 12 multiplied by 20, and this becomes a 400. So therefore machine time which is going to be used is going to be 400 units, whatever the unit was, hours, days, whatever. Okay, moving on to the next question. Question number 6.3. It says the function f is given as follows. For some constants a and b, given f 0 is equals to 8. So when x is equals to 0, as in we'll have a over 1 plus 0 square plus b into a 0 plus c. The answer should be an 8. So we have a plus c. This is just my equation 1. Then it says I need to put the value of x as 1. Okay. Then we'll have a 1 plus 1 square plus b plus c. And this should be a 3. So a over a 2 plus b plus c. So therefore a 6 is equals to a plus 2b plus 2c. Oops, my baby's awake. I'm gonna go see if... Oh, he's gone back to sleep. Lucky me. Oh no, he's awake. I'll be back. Yeah, he just cried for like 2 seconds and just ran back to sleep himself. Okay, let's continue. A over 1 plus 2 squares of 4 plus 2b plus c. And this should be equals to a minus 8 over... No, the monster's awake. I'm gonna have to stop the video again. Okay, I'm back. So let's take a common denominator. This becomes minus 8 is equals to a plus 5 2s are 10, b plus 5 1s are 5, 5c. Okay. So now we have our system of 3 equations and 3 unknowns. we have a 1a plus 0b plus 1c is equals to an 8. Then we have a 1a plus 2b plus 2c is equals to a 6. Then we have a 1a plus 10b plus 5c is equals to a minus 8. So when we put this in matrix form, I'll have a 1, 1, 1, 0 to 10, 1 to 5. My unknowns are A, B, C. My restraint is 8, 6 minus 8. Okay. So let's convert this into matrix form, augmented matrix form. This comes here, and we have an 8, 6 minus 8. Remember, I want to use row 1 to impact rows 2 and 3. So I'll have a row 2 minus row 1, and I'll have a row 3 minus row 1. So I'll end up with the following. A 1 minus 1 is a 0, a 2 minus a 0 is a 2, 2 minus 1 is a 1, and 6 minus 8 is a minus 2. Then a 1 minus 1 is a 0, a 10 minus 0 is a 10, 5 minus 1 is a 4, and minus 8 is a minus 16. Okay, now I want to make this into a 0. So what I can do is I can do row 3, and I have to impact row 3 using row 2, remember. So I'll have a row 3 minus 5 into row 2, because I know 5 2s are 10. Okay, so row 3 is being impacted, the rest will remain the same. This is a 2, 0 is a 0. Then 4 minus a 5 is a minus 1. Then a 16 plus 5 2s are 10 will be a 6. A minus 6 actually, because 16 is greater. Okay, so now we can just work backwards. So a minus c is equals to a minus 6. So c is just a 6. Then we have a 2b plus c is equals to a minus 2. So 2b is just a minus 2 minus c, which is a minus 6. So we have a 2b is equals to minus 8. So b is equals to a minus 4. And the last equation, which is basically the first row, it tells us that a plus b is equals to an 8. So a is equals to 8 minus a b. So this is a 8 plus a 4, and we have 8, 9, 10, 11, 12. So we have a 12 here. So let's check our answer. Oh, sorry, this is actually a C. Sorry. That was the last. Yeah. So this becomes a minus 6. So it's a 2. Okay. So what else? Okay. Solve the system using a matrix. That's what we wanted to do. Yeah. So this question is done. Oh, yay. We only had 3 practice questions, and in the next video on chapter 6, I will solve the sample examination questions given in the study guide. I hope this video was useful. I got interrupted many times by my crying baby, which was a huge distraction during this class. But I hope this class was still helpful. Okay, I'll see you in the next one. Take care.